Dear students, in this lecture I would like to start the chapter partial differential equations. We start this chapter by formation of partial differential equations by eliminating arbitrary constants. It is a topic which is much similar to topic which you may learn from class 12, where you formed ordinary differential equations by eliminating arbitrary constants. Let's start the topic. We are given with an equation 9.1 f x y z a b equals to 0, where a and b are given as arbitrary constant and the remaining three x, y and z are variables, where z is supposed to be a function of x and y. That is, z is a dependent variable while x and y are independent variables. And we solve the problem similar to class 12, where we differentiated the given equation with respect to, say, variable x. Only one variable was there, only one independent variable was there in class 12. Here we have two independent variables, x and y. That's why we partially differentiate equation 9.1 with respect to x and then with respect to y. With respect to x, we get equation 9.2, that is del f by del x, as f is function of x, y, z, a, b, where x, y, z are variables. So with respect to x, we have del f by del x plus, as it is function of y, which is to be treated as a constant while partially differentiating with respect to x, but z is function of both x and y. That's why we are partially differentiating f with respect to z, which came as del f by del z into del z by del x, because finally we have to partially differentiate equation 9.1 with respect to x. That's why del z by del x is also multiplied. Equals to 0 is obvious result in right hand side. Similarly, by partially differentiating equation 9.1 with respect to y, we obtained equation 9.3. Now, by using all three equations, 9.1, 9.2 and 9.3, that is three equations in total, we have to eliminate two arbitrary constants a and b, which is an ideal scenario, because in mathematics, if we had to eliminate n constants, that is, we need n plus 1 equations. So here we have to eliminate two constants a and b, and for the purpose we have three equations, 9.1, 9.2 and 9.3. So by some mathematical calculation, finally we will find an equation in shape of 9.4 here, gxyz pq equals to 0, where that p and q are standard symbols. P means del z by del x and q means del z by del y. That means partial derivatives of z with respect to x and y. That's why we consider it as a partial differential equation. So that is how we can form a partial differential equation by eliminating arbitrary constants. Dear students, now we will solve several problems for formation of partial differential equation while eliminating arbitrary constant. Question number 1. An equation x square upon a square plus y square upon b square plus z square upon c square equals to 1 is given, where we actually have three arbitrary constants a, b and c. So we have to look forward towards three more equations in addition of the given equation, that is four equations in total, so that we can eliminate a, b and c. And for the purpose, we start the proceedings by partially differentiating given equation with respect to x and y, and in that process we obtained equation 1 and equation 2. Now we need, as I already told, one more equation at least, so that we can find the result. And for the purpose, we further partially differentiate equation 1 with respect to x and equation 2 with respect to y, just to get some additional result. Otherwise, just by differentiating partially with respect to x, we can complete our purpose. So we now have equation number 3 and 4, that is partially differentiating 1 with respect to x comes in shape of 3 and partially differentiating 2 with respect to y comes in shape of 4. Now from equation number 1 we can easily observe the value of c square, and we are doing this all because now we have to eliminate a, b and c. So we obtained value of c square, that is value of c ultimately, in form of equation 5, and substituting this value of c square in equation number 3 and dividing whole equation by a square, we obtained minus z by x del z by del x plus del z by del x whole square plus z del 2z by del x whole square equals to 0. Then we simplified that equation finally, which ended into form of equation number 6, where a, b and c all three are absent. That is, we eliminated a, b and c, and in equation 6 we obtained x, y, z and partial derivatives of z with respect to x and y of any order. So a partial differential equation is obtained, and as I earlier told in the solution, that we can find one additional solution here, and for that we combined equations 2 and 4, and the result or additional result came in shape of equation number 7. Here one important point is to be mentioned, that as I told, we have to eliminate all the constants in this process, and for that we actually need the given equation along with several equations obtained by partially differentiating the given equation. Say for eliminating 3 constants here, we obtained 4 equations and we used those equations, but actually it is not required in all the problems that you have to use all n plus 1 equations to eliminate n constant. There may be the requirement of least number of equations for eliminating the given constant in any other problem. Now we form one more partial differential equation by virtue of question number 2, where we have to eliminate constants by an equation of spheres whose centers lie on the z-axis. And we all know that an equation of a sphere whose center lie on z-axis can easily be expressed or obtained as x minus 0 whole square plus y minus 0 whole square plus z minus c whole square equals to c square, because its center must be 0, 0, c type. And by simplifying, the equation is written as x square plus y square plus z square minus 2c z equals to 0, having only one arbitrary constant, say c. And for finding or forming the partial differential equation, we start the proceeding and we partially differentiate the given equation with respect to x and y. By doing that, we obtain equation number 1 and equation number 2, and using equation number 1 and 2 in a certain combination, which you can see equation number 1 multiplied by q, equation number 2 multiplied by p, we obtained equation number 3 and 4, and we obtained equation number 3 and 4 just because of a certain purpose. Our purpose is very clear, that we have to eliminate constant c, and equation number 3 and 4 are obviously there for this purpose. And if we subtract equation 3 by 4 or 4 by 3, we easily obtain the result as py minus qx equals to 0, means a equation free of constant c, and it is having xy as variables and p and q as derivatives. P always means del z by del x and q always means del z by del y. And dear friend, for the rest of this chapter of first order or any degree partial differential equation, these symbols are to be treated in this special manner. Means P is always to be considered as del z by del x, and Q is to be considered as del z by del